Hey guys, we're going to start with a little bit of factoring review today to lead us into our next unit. And specifically, we're going to be looking at factoring trinomials. So a trinomial is in the form of ax squared plus bx plus c. So basically, you have an x squared term, a number with it, an x term with a number with it, and a c. And technically, we could be missing a c term or an a term or a b term, but this is the most that we'll ever have. Now, the most important and the first step in factoring is what we call our greatest common factor. Your first step in factoring is always to factor out your greatest common factor. And we often just refer to this as our GCF. So your GCF is the biggest number or variable that goes into all of your terms. Okay, so let's look at number 1. Let's start simple. Let's try 9x plus 36. So we're looking for the biggest number and variable that goes into both of these terms. So here, the biggest number that goes into both of them is 9. So our GCF is 9. So 9 goes on the outside of our parentheses. It's like we're undistributing this 9. And what I do next is I'm dividing each term by 9. So 9x divided by 9 is x, plus the 36 divided by 9 is 4. And I can redistribute the 9 to check my answer as well. All right, let's try 16p to the 4th plus 4p cubed. So to identify my GCF, the number part is the biggest number that divides evenly into 16 and 4. The biggest number that divides evenly into 16 and 4. So the number part would be 4. Now I need to look at my variables here. Both of them have p's, so I can factor out at least one p. The first term is a p to the 4th, and the second one's a p to the 3rd. So they all have at least 3 p's. So I can factor out a p cubed. So when I factor out a 4p cubed, I'm basically dividing each term by 4p cubed. So 16p to the 4th divided by 4p cubed would be 4p, plus 4p cubed divided by 4p cubed is a 1. All right, so you're always going to check for a GCF first. That's always going to be the first thing that you do. Next, depending on what the problem looks like, is the next method of factoring you're going to use. So our next method of factoring is what we call difference of squares. And you are going to use this method whenever you are subtracting two perfect squares. So for example, if I had a squared minus b squared. So a is a squared number, b is a squared number, and I'm subtracting them. If this happens, you would factor it in the form of a plus b times a minus b. So what will happen is you'll take the square roots of both. One will be plus and one will be minus. Oh, and you may be asking, what are your perfect squares? So perfect squares are numbers that have nice square roots. So 1, 4, 9, 16, 25, 36, 49, etc. Variable-wise, x squared, x to the 4th, x to the 6th, x to the 8th, and so on. All right, so let's try a couple of these. So number 3, let's do 25x squared minus 36. So remember, our first step in factoring is our greatest common factor. There is nothing, or there's no number besides 1 that's going to go into 25x squared and 36. So our method of factoring here has to be difference of squares because we're subtracting two perfect squares. So 25x squared is the perfect square of 5x. 36 is the perfect square of 6. So when I factor this, this would factor into a 5x plus 6 and a 5x minus 6. And this will be our answer. So basically we take the square roots, 1 parentheses plus and 1 parentheses minus. All right, let's try another one here. Let's do 1 minus 9x to the 4th. 1 minus 9x to the 4th. So notice they're both perfect squares, so we're good there. Now, I'm subtracting them, so we're going to use difference of squares. There's also not a GCF between these two. So 1 is the perfect square of 1. 9x to the 4th is the perfect square of 3x squared. So this will factor into a 1 plus 3x squared and a 1 minus 3x squared. And I would recommend keeping the same pattern between them. So the 3x squared was the second term. Keep it in the second part of both parentheses. All right, so I'd like you guys to pause this video and try number 5. Pause the video, try number 5, see if you can get it. Okay, you should end up with an x plus 12 and an x minus 12. Okay. All right. So we've learned two methods, or reviewed two methods. Our first step is greatest common factor. Now, if we're subtracting two perfect squares, we'll use difference of squares. The last method we will review today, you may have learned it without a name before. I call it the factor sum method. So it is for trinomials. So ax squared plus bx plus c. We don't need that parenthesis part there. Where a equals 1. So there's no number in front of our x squared term. So for example, let's look at x squared minus 13x minus 30. So how we factor using factor sum is we look for factors of our c term. So this is our number without a variable. So here this would be factors of negative 30. That have a sum, which means they add to our b term. So for this problem, it would be a sum of negative 13. So two numbers that multiply to negative 30
and add to negative 13. Factors of negative 30 that have a sum of negative 13. There's only ever going to be one set of numbers that will work. Now these two numbers should be negative 15 and positive 2. A lot of you guys might have thought, oh, I could do 3 and 10, and since it's a negative 13, make them both negatives. But these multiply to a positive 30. So those pair of numbers will not work. So this will factor into an x minus 15 and an x plus 2. All right, let's try a couple more. So let's look at x squared minus 13x plus 12. X squared minus 13x plus 12. So here we're looking for factors of 12 that have a sum of negative 13. So two numbers that multiply to 12 and add to negative 13 would be negative 12 and negative 1. So this would factor into an x minus 12 and an x minus 1. Let's do some more. Let's try x squared minus x minus 12. X squared minus x minus 12. So here we're looking for factors of negative 12 that have a sum of negative 1. So two numbers that'll multiply to a negative 12 and add to a negative 1. These two numbers should be a negative 4 and a positive 3. A negative 4 and a positive 3. So I get x minus 4 and x plus 3. Now if we wanted to always check our answers, we could distribute them out and combine like terms. All right, I'd like you guys to try this one. X squared plus 9x plus 20. So go ahead and try this one. Pause the video and try this problem. All right, so for this one, it should have been factors of 20 that have a sum of 9, which should have given you 4 and 5. So you should get x plus 4 and x plus 5. Now the order of your parenthesis does not matter. So plus 5 and plus 4 is the same thing as if I had 5 and 4. It's just the signs. So they're both positive, so they both need to be positive. So now we're going to look at some combinations. So remember, we always start with GCF. And then sometimes after we do a GCF, we can do another method. So combinations include a GCF plus another method. So let's look at 2x squared minus 50. 2x squared minus 50. So first thing I want to do is always check for a GCF. Here, is there a number that goes into both 2x squared and 50? Hopefully you say yes. 2 can go into all of these. So I have a GCF of 2. So I'm going to factor a 2 out from each term. And when I do that, this leaves me with an x squared minus 25. Because I divided each term by 2. Now this inside, x squared minus 25, it won't always, but sometimes you can continue to factor this. X squared minus 25 here is a difference of squares. okay, because I'm subtracting two perfect squares. This is x squared and 5 squared. So this will factor into an x plus 5 and an x minus 5. Because remember, difference of squares, you take the square roots. One's plus, one's minus. And then our GCF of 2 just hangs out in front. All right, one more. Let's do 3x cubed plus 18x squared plus 24x. So I've look now at GCF, I have 3 terms here, so it has to go into all 3 terms. So a number or variable that goes into all 3, well, between 3, 18, and 24, 3 can go into all of them. And all 3 of these have at least one x. So my GCF is 3x. So the first thing I'm going to do is factor out this GCF of 3x, and then I'll divide each terms by 3x, which will leave me with an x squared plus 6x plus 8. An x squared plus 6x plus 8. Now again, sometimes when we check on the inside, we can check to see if we have another method of factoring. Here I have a trinomial, so 3 terms, and the number with our x squared is 1. So we can use a factor sum on this inside part. So I'm looking for factors of 8 that have a sum of positive 6. Factors of 8 that have a sum of positive 6. These two numbers should be 2 and 4. 2 times 4 is 8, and 2 plus 4 is 6. So this factor sum would factor into an x plus 2 and an x plus 4. And we'd still have this 3x in front.